By February of 2023, scientists around the world confirmed something that had been quietly brewing in the cosmos. Betelgeuse, the red supergiant star in Orion's shoulder, was acting far more strangely than anyone had ever documented. For generations, it had pulsed like clockwork, swelling and shrinking in brightness in a predictable 400-day cycle. But now, that rhythm had vanished. The once steady heartbeat of this stellar giant had turned erratic, faint, and disoriented. Yet, against all predictions, it didn't explode. It didn't collapse. It just hung there, smoldering, unpredictable, and oddly captivating. This wasn't just another hiccup in a dying star's life. It was a dramatic signal, something new, something we hadn't seen before. What was Betelgeuse trying to show us? Let's rewind a bit. Betelgeuse isn't just any star. It's enormous, so huge, in fact, that if it replaced our Sun, its surface would reach out past the orbit of Jupiter. It's one of the most massive stars visible to the naked eye and among the brightest in our sky, casting a distinctive reddish hue that has drawn the attention of astronomers and civilizations for centuries. But Betelgeuse is old, by stellar standards. It's living on borrowed time. It's nearing the end of its life, and when stars like this die, they don't go quietly. They go out with a bang, a supernova explosion so powerful it could briefly rival the brightness of an entire galaxy. That's why, when Betelgeuse began to dramatically dim back in late 2019 and early 2020, scientists and skywatchers alike took notice. Some believed it was finally happening, that the long-anticipated supernova was upon us. But that's not what unfolded. Instead, what followed was something entirely unexpected. Betelgeuse had ejected a massive portion of its surface, a titanic surface mass ejection, or SME. To give you an idea of scale, this eruption was estimated to be 500 times greater than any coronal mass ejection our Sun has ever produced. Imagine a piece of a star's outer shell, as massive as several Earths combined, being hurled out into space. The sheer energy required for such an event defies imagination. This wasn't just a surface hiccup. This was Betelgeuse shedding a part of itself in what might be the stellar equivalent of a nervous breakdown. Since then, Betelgeuse has been in recovery mode. Its internal structure is trying to stabilize. The shockwaves from that eruption are still reverberating through its outer layers. And the regular pulses we once used to measure its life signs? They're gone, or at least heavily disrupted. Its brightness continues to fluctuate, but in ways we can't fully predict. This unpredictability has thrown our understanding of stellar life cycles into question. So, what does all this mean? Are we closer to the supernova than we thought? Well, not quite. While the eruption was massive and unprecedented, the prevailing consensus among astrophysicists is that Betelgeuse still has some time left. Maybe tens of thousands of years. Possibly even 100,000. That's both comforting and humbling. We likely won't witness the supernova in our lifetimes, but the universe, ever full of surprises, isn't one to stick rigidly to our models. And the fact that a red supergiant can throw off part of its surface like this has introduced a whole new layer of mystery. Could there be signs of impending collapse we've never recognized before? Could other stars be following similar hidden paths toward their explosive end? If Betelgeuse did explode tomorrow, what would happen? Here's the awe-inspiring part. It would be brilliant, literally. The supernova would outshine every other object in the night sky apart from the moon. It would be visible during the day, even with the sun blazing overhead. For weeks, perhaps months, it would remain a glowing, ghostly light in our skies. Cultures across the globe would look up and see the death of a star written in the heavens, an event as beautiful as it is rare. And despite its apparent nearness, Betelgeuse is far enough, roughly 650 light-years away, that Earth would be completely safe. The radiation and debris would disperse harmlessly by the time they reached us. But beyond the sheer spectacle, there's a more profound significance to all of this. Betelgeuse reminds us how dynamic and mysterious the universe truly is. We often think of the stars as static beacons, unchanging lights dotting the sky since before humans walked the earth. But the truth is, stars are living, breathing systems. They're born in fire, live in cycles of fusion and pressure, and die in colossal displays of cosmic violence. Betelgeuse is not just a star, it is a living process unfolding before us, an unpredictable drama written across the fabric of spacetime. Its recent behavior has sparked a new wave of research. Telescopes around the world, and in orbit, are watching Betelgeuse with renewed urgency. Space-based infrared observatories have captured the cooling cloud of dust still drifting away from the star. Astronomers are measuring its surface temperature, mapping its pulsations, and tracking every flicker of brightness. The hope is to decode the new language Betelgeuse is speaking. A language of stellar change. Of decline. Of transformation. Perhaps, in these subtle signals, lies the key to understanding how other massive stars will behave at the brink of collapse. Perhaps, Betelgeuse is not just an object of curiosity, but a guide to the endgame of stellar life. So the next time you're outside at night, look up and find Orion, the hunter etched in starlight. Focus on the glowing red star at his shoulder. That's Betelgeuse. And realize that what you're seeing is something extraordinary. A massive, ancient, trembling star, undergoing changes so profound we're still struggling to grasp them. A celestial drama unfolding 650 light-years away. One that we're lucky to witness at all. This has been Waves Discovery. If the story of Betelgeuse left you in awe, help us share the wonder. Like, subscribe, and join us on this endless journey through the cosmos, where every star has a story, and some are burning right now, waiting to be told.